Okay. So, as we said that we are discussing about some speech application. So, my idea is not to details go about that speech synthesis, speech ASR, because that if I go for the speech synthesis in details, then it will take another 4 to 6 lectures. So, I am not going details. So, and same things for ASR also, that automatic speech recognition. What I will do, I will basically describe what is ASR, what are the technology involved, and challenges in ASR also I will describe, so that you can take some project and you can as a student you can do some project on that challenges, or as a teacher you can give that project to other students also to pursue in that area. So, my idea is not details discussed about the ASR, but raise those issues which are involved in ASR and which are present in current scenario also. So, if I say that ASR like the TTS, if I say ASR, automatic speech recognition. So, automatic speech recognition. So, what is the automatic speech recognition means that if I have a machine and I have a microphone, if I talk to the machine, machine should understand, not only this is understanding, I am not saying understand, machine should decode what linguistic message is there in the speech signal. That means, suppose I uttered a sentence, machine should recognize each and every word of the sentence. I am not saying understanding purposely. Speech understanding is different issues. So, that issue I will come. So, ASR means I provide a input which is nothing but an acoustic signal, and from the acoustic signal it should convert the linguistic information, only the linguistic information like the words which is contained in this utterance or sentence which I have spoken. So, either I may say single word may be a sentence, or several words together, W1, W2, W3, W4 may form a sentence. Maybe some sentence I can say that open this folder, or I can say open. So, either it may be a single word or it may be a string of words. So, that should understand by the machine, that is ASR. Now, application of ASR, there are several applications. Tell us that most common application, if you see in your mobile phone, there is an ASR. If you say home, then it will dial home. If you say friend, if you store in name of your number, friend number, then the mobile dial friend. So, there may be a single word, command, the command recognition. Or if you see in the speak in the Google search engine, that is available. In the Google search engine, if you say search this or that restaurant name, then Google will search the restaurant name and show you the restaurant name, restaurant place and other things also. So, that means it provides a hand-free operation with the machine, or it is a man-machine communication. Man communicates with the machine. Okay. So, that may be a command, that may be a dialogue, that may be a, even I prefer that something like that. The main drawback in Indian language content in internet, if you see the typing of Indian language is not so easy because it is composite script. So, if I developed a ASR, I just speak on the front of the machine, machine will type what I am speaking. Then it is fast operation. So, man-machine communication. Even somebody does not know how to write, but he knows speaking because the spoken language is the natural language for the human communication. So, even I do not know that how to write the language, I can speak. So, if I speak in front of the computer and computer understand what I want, then nothing like that application. So, all kinds of application, different kinds of ASR is required, but basic technology, how we develop the ASR, that depends that from the acoustic signal I have to find out the word what I have said. Okay. So, anyhow I have to do that thing. So, now if you see the basic idea that what is speech recognition, that there is a speech signal, I have to find out the let's word W1. So, it is nothing but that I should know which word I have spoken. So, machine should learn that. So, machine should learn the words with the acoustic signal. So, from the acoustic signal of the training data, I learn the machine, and which is called model generation. I learn the W1 model is generated or machine is learned. Then if I said that word, based on the learning of the machine, machine should match the pattern and say, okay, you have said this word. Okay. So it is nothing but a pattern matching algorithm, I can say. Language model, all kinds of things I will come later on. So nothing but acoustic signal. Machine will, how the child is developed, the recognition system is developed. So it is speech perception, not speech production. So when the child learning some vocabulary, you see, he listen it, and time listen it, and then it is memorized. So he learning that one word by one word, and then once he learn, then he can, whatever I say, he can recognize. Similarly, machine also, machine has to be learned the word, and then word, sentence, phone, whatever you said, and then machine has to recognize from the input signal of speech signal. Okay, so that is ASR. Now what is problem? If I say, let's think about only simple word recognition problem. Suppose I spoke a word, let's speech, SPEECH. Okay, then I think, okay, there will be acoustic waveform of the word speech. Okay, now let machine learn this, or machine store this. Then I said speech, then that acoustic output has to be matched with this acoustic what the machine has already stored acoustic signal, and if the signal is matched, then I said speech. Okay, so speech, that word is stored, and then there is a, so how I match the signal, that is pattern matching, that will come later on. How I match the signal, that is AI or pattern matching, artificial intelligence, pattern matching, classification, SBM, neural network, all kinds of things are there, pattern matching. I am not going to the pattern matching directly. Let's say there is a speech signal is there, speech, spoken form of the speech is there, that means acoustic signal of speech, and if I say speech, it compare with the machine stored acoustic signal, and anyhow some algorithm is used, and it match these two things and give the output speech. So purpose is solved. Okay, but what is the problem? Problem is that if you say speech this time, if I next time I say speech, the two waveforms are not identical, because machine cannot or man cannot produce two identical waveforms. Or this time I said speech, this next time I say speech. So there is a length of the word has also a problem. Okay, so that problem, so those kind of variability is the problem. Now I stored only speech for speaker 1. If a speaker 2 said speech, then also have a problem. Okay, so that uncertainty, how do you compare the input with known patterns? That has a problem. How to solve this kind of problem? Second thing is that word pattern matching, large vocabulary. How many words I will store for any language? There is a huge number of words. If I store many words, and then there is a probability of becoming same word, you can say the phonetically similar word will be increased. I said, suppose I said, as I give you in that problem, the problem in I think in week 1 lecture, that based on the manner of articulation I can identify the words. But if the similar kind of words are there, like Baba and Kaka is there, Baba and Kaka, this kind of word, then I said the difference between the two words is only this is Ba and this is Ko. But if you see, Ba is also a stop consonant, Ko is also a stop consonant. So identify between these stop consonant by only place of articulation, because this is also voiced. Okay, occlusion period is voiced, but it is a stop consonant. This place is bilabial, this place is less velar. So I have to identify the place. So identifying the difference between the two signals will very less. So if my vocabulary size is increases, the similarity words will be increases and recognition will be fall down. So complexity of pattern matching will be increases. Then absence of word boundary, yes, this is very important. If I develop the word model, but if I say I will go to Calcutta, but the speech signal is very complex. If I say speech signal is very complex, let's now if you say this is a word, this is a word, this is a word, this is a word, this is a word. In written, the word boundary are definite. Word boundary are there. But when I speak this one, if I open that acoustic signal of this boundary does not exist, because this is a co-articulatory event. Speech signal is very complex. So there is no definite word boundary in the spoken language. So I cannot say speech is a word. How do I identify speech is a word from a spoken word, spoken sentence? But if it is isolated word, is okay. I can know that only word is spoken. But if it is a continuous speech, word boundary are absent. But in case of isolated word also, I said the single, I cannot reproduce exactly same word twice. Then if I say there is two words like that, ice cream and ice cream, those pronunciations are same, ice cream and ice cream. Which word I want to say, I don't know. The acoustically they are similar. So those are the problem in speech recognition. There is other problem also. Human physiology, physiological change. Suppose today I say some word, then I got cold and cough, and I say the same sentence, but the acoustic signal will be different, because there is a physiological change happens in here, so there will be different. Similarly, the words spoken by a male voice and female voice will be problem, because male format may be the higher side, male format may be lower side, female format may be higher side, so all kind of variation will be there. Then speaking style, every person has different speaking style. The same word speech, I say speech, somebody says speech, somebody says speech, signals are different. Speaking rate, I may say fast, somebody say very slow. Then emotional state, if I am happy, my signal will be different. If I sad, signal will be different. Emphasis, English is a bound trace language. I will come that later on. Bound trace language, but Bengali is an English is a contrastive trace language. Bengali is a bound trace language. So if I am saying whatever the English I am pronouncing, it is not exactly bound trace English. Similarly, emphasis and there is accent, dialect, foreign word variation. If you see the dialectal variation, very complex issue. Same word, if there is a dialectal variation, the pronunciation is different. Accent difference. Foreign word, if I say, suppose there is a Bengali person is pronounced Jew, how they pronounce? They pronounce Jew. If it is spoken by an, you can say the convent educated person, then he pronounced Zoo. But a Bengali person whose first language is Bengali, he said Jew. Jew, although it is a foreign word, but when I pronounce in my style, not that whatever said by that foreign language style. So that all variation will be there. Same things will happen, that I developed a English English recognizer. Based on that, I take that one kind of dialectal English, like that. I train that using timid database. You know the database, timid database. I train it ASR. Then if I train it by timid database, and then I try to recognize the Bengali person whose first language Bengali is spoken in English, then there is a lot of misconception is there. Misrecognition is happening. Word error rate is increased. So all kinds of accent, dialect, foreign word variation is environmental and background noise. I recorded speech in a studio environment, and when I testing it my mobile phone, I recorded the speech in studio environment, and machine is trained that, and after when I providing the machine the test speech, that is recorded on a factory environment. So there is a lot of background noise. How do you eliminate the background noise? So all kinds of problems are there in ASR. That's why there is you see there is a lot of long history of ASR development. Okay. So history, if you say, then this is the history. So trend started with feature based method, then template matching method, rule based method. Today statistical methods is most usually methods, and right now there is a research trend in deep neural network based ASR system. People are trying to develop the ASR system using the deep neural network method. Every method has a pros and cons. Statistical method, rule based method, template matching method. So I just go one or two methods so that you understand the deeper issue of the ASR. Like template based method, I describe the template based method. So what is there? It is nothing but a template means. So template means that suppose I have, like let's say that I have a rectangle. It is a template. Okay. Now I produce similar rectangle, and then I say, okay, this is a rectangle because this matched with this. So this is a template which is stored in computer or stored in machine, and I have given a test template, this one. So they match stored template with the given template. If they match, found match, then declare this given template is nothing but a this, because this has matched. So I have a in machine I have given a rectangular template, then circular template, triangle template, and like this kind of template I take. Then if I provide a test template with circle, then it try to match with this. If it is matched, then say it is a circle, because the template is said circle. Similarly in ASR, what they said, there is some words. This is template based matching is using in word based, like that. Or whatever you are doing in mobile, that when you say home, when you record, when you store the home and the number, you have pronounced home. So that home word templates are there in the mobile phone. Now when I produce home in microphone and I give this acoustic signal to here machine, then machine try to match whether this template matched with this template or not. So there may be a home, there may be a friend, there may be a school, all kinds of words are there, and once I get this template, try to match with template of all words, and the best matching template will declare, okay, you have said this one. Okay, that is called pattern recognition. Matching between the two things is pattern recognition. So how they match, there is different kinds of algorithms are there. They are initially used vector quantization, dynamic time warping, hidden Markov model, and then today neural network, then artificial neural network, then there is a today deep learning is a very big topic. Today people are using deep learning for template matching or any kind of classification, support vector machine. So any kind of classification technique I can find out whether the two templates are matched or not. Okay. Vector quantization initially this was very much used in speaker identification. In last week I will take one class on speaker identification, because I will just describe the problem, and then I will say that how the vector quantization is used in there. So basically vector quantization is nothing but creating a you can say the training vector. Suppose if I say speech 10 times, every time there is a different speech I produce. Now should I store all 10 speech in machine, or I can say from the all 10 speech manage a representative vector, that is speech. Okay. So the vector quantization is quantized. What the issue is same as quantization issue. The quantization issue is there. If you remember in my the digital quantization class, what I said, I have said I have divided the pass 5 volt in 8 bit, then I divided this plus 5 volt to minus 5 volt in 256 levels, and each level changing by single bit. If it is fine, then 127 plus and 127 minus. Okay, and I said that all this voltage level, this delta, will be represented by only single representation, that line. So whatever the voltage within this limit, maybe I say it is fall in here. Once it cross here, then I said it is represented by here, this line. So I quantize that continuous 5 volt in some sort of a level. So same things is happen. So suppose I have a feature vector x1, x2 up to xn is a feature vector. I have collected all kinds of feature vector. Then I said x1 has a variation from, it is x1 varies from 0 to 10. I said generate 5 vector within the variation of 0 to 10. So I can say 0 to 10 is divided in 5 levels. Or I can say 0 to 10, let's the variation of x1 is started from minus 10 to plus 10. So 20 is the variation. So I said, okay, there is a 20 variation is there. Let's equally divided that variation with a 5. Then 5 division will be straight. So that is vector quantization. If you read this slide, you can understand that code book and vector quantization. Details I will discuss later on in speaker identification problem. So it is nothing but distance measuring. Important issue where the speech recognition is start. Dynamic time warping, which is very important. It leads to that you can say that dynamic programming. From here it is started. So what is the problem? Problem, if you see, there is a 2 utterance A and B. Let's first utterance is, it is a speech or something else. Something is uttered from one unvoiced, then voiced, then unvoiced, then voiced, like this. Same word is uttered 2 times. The length is differ. It is 2 different lengths. Okay. Now, if this word is stored in my machine and this word is I want to match with this thing, they cannot match, because I cannot match whole words with the whole word. What I say, I am comparing let's 0 to 10 millisecond of here with here 0 to 10 millisecond. Then if this portion I compare with this portion, the distortion is high. So it said no, this cannot be the word. So this is not correct matching. Have you understand or not? Suppose I have a, look, forget about this example. Suppose I have a speech. Okay, this length of this signal is let's 10 milliseconds or let's 1 second, and next time I pronounce speech I pronounce, the length is 1.5 milliseconds. So if I frame it, whatever the framing I have done, parameter extraction I have done, let's LPC parameter for 100 frame per second, 100 frame per second. So this give me the 100 frame, this give me the 150 frame. Now I try to match 100 frame with 150 frame. So there will be time alignment. If there is a mismatch in time alignment, so I may compare this signal, this portion of signal with this portion of signal. But see that this signal can compare only this signal. So what I want, the 2 sequence, 2 number, although there is a number of frame is different, but I want the frame should be compared with similar type. So I want either this 150 frame should be warped to 100 frame, or I can say this 100 frame representation can be warped to 150 frame. Any one I have to do. So many frame will be same. I can say okay, frame 1, let's frame 1 is compared with frame 1, frame 2 compared with frame 2 of this one, and then frame 3 of this one is compared with here frame 3. Next time also frame 3 is compared with frame 4 is compared with frame 3, then frame 4 is compared with frame 5 is compared with frame 3, until unless the distance between the 2 frames is very high. Then I can say, I can say this is 100 frame 1 to frame 100, but once I compare, this is frame 1 to frame 150 within that time also, because I have not jumped. Okay, so that is dynamic time warping. So time frame of this signal is warped as per the stored data. Okay, so from there the best. So I want. So what is, if you see here time frame A and here time frame B. I want the best possible match path and maximum distortion. I find out the distortion between the two things, and if it is within the limit, the frame jump will be not happen. If the outside the limit, I say the frame jump is happen. Here within the limit, so frame jump is not happen. Frame jump is not happen. Frame jump is not happen. So that way I can time warp. Details you can go through. So this is dynamic time warping. So template matched with time aligned with test things. So it can scatter to the variation of speech rate, but it cannot. I don't know whether it is scattered to speaker variation or not. So all kinds of other kind of technology I have to use. Okay. So there is a lot of techniques of A search are developed. Lot of sophisticated pattern matching techniques are developed. SVM, support vector machine. There is a neural network. There is a now today in all research are going to the deep neural network, DBN, deep belief neural network, deep neural network. So all DNN. So all kinds of things are happening. Okay. I am not reading out the slides. Now next class I will discuss this one, that state of art speech recognition system. What is their problem? What are the research issues are there in state of art speech recognition problem issues, and there is a less resource. What is the requirement of this kind of statistical model, and what is the problem in race language? What are the alternative solution? What are the research going on in this direction? I will discuss in the next lecture. Okay, thank you.